All right. So, hello, welcome into my channel. Happy Thursday. I hope everyone's doing well. And I am Professor L, and I'm doing live stream for math. So, if you have a math problem you want to see me work, you can post those in the chat. And I'm just going to go ahead and get into it. I am solving another system of linear equations with two variables. And so what I'm going to do is I'm going to go ahead and go through that method of Gauss-Jordan elimination one more time, just to practice, and hopefully moving towards solving a system with three unknowns next time, the same method. So I will go ahead and just get into it. Hope everybody's doing well. And I'm pulling these problems from my linear algebra textbook. And yeah, you see, I'm trying to work towards getting this pretty concise. So I'm going to try to not interrupt myself 20 times and see how this goes. And one of these days I'll have the board erased before my live stream. That would be awesome. All right, so we have this system. I have one more 2x2, and then what we'll do is next time we'll get into the three equations, three unknowns. So this is 2x plus 2y, and it equals 4. And the directions say that there is a unique solution. I have not found it yet, but what we'll do is we'll graph it in the end. So 3x plus 2y, and that equals 3. So we have this little system, and we're just going to go through the method. What we're doing is we're taking the coefficients of my variables, and we're creating a matrix. It's a 2x2 matrix, and we're just listing the rows and columns. So we've got 2, 3, 2, 2. And what we're going to do is we're going to augment it with the constants here. So I'm just going to list the constants, 4, 3. And we're using this concept called the identity matrix, okay? And the identity matrix is bound by putting a 2x2 matrix in what's called reduced echelon form. And basically, essentially, you have 1 in the diagonal and zeros in the backslash. And so what I want to do is I'm going to perform a series of row operations on this system right here so that the identity matrix appears here, and then I just have something left over here. And when I've done that, I've essentially solved this system and the solution's here. So let's go ahead and do it. So first of all, what I want to do is I'm going to go over the rules. You can swap out any two equations, or rather rows. You can also add rows, and then you can also multiply the rows by scalars. So there's 3 main rules, and those are called elementary row operations. So what I want to do is solve it in as least amount of steps as possible. So it's almost like you're employing this concept, an ounce in time will save 9. So kind of thinking ahead and looking at all of the options, trying to come up with the best solution, like the best first step. So there's many different steps. You could take an unlimited amount of steps, and it could take you all day. But yesterday I was able to solve it in like 2 or 3. That's probably because it was a simple one. Anyway, I'm noticing here that I have 2's here, and I also have 3 and a 2. So if I multiply the first row by a -1 and then add it to row 2, I can make this, and then I'll replace row 1. This will become a 1, and then this will become a 0. So I think that that's probably the best first step. So let's go ahead and do that. We're going to do -1 row 1 plus row 2, and we're going to replace row. We'll replace row 2. How about that? And just see where it goes. So I'm going to draw my new matrix. multiplying everything in row 1 by -1, it's going to get written here because we're not replacing row 1, we're going to replace row 2. So -1 times 2 is -2, -2, and we have -4. And then I'm going to add row 1 and row 2 now. So I have 3 plus a -2 is going to give me 1. And then 2 minus 2 is 0. And then we have 3 minus 4 is -1. All right. And so I've essentially solved this one because it's already in this. The whole thing isn't in reduced echelon form, but this, you notice here, this is my value for x. Okay, so I've already found x by just swapping these two out. However, I need to solve the whole thing all at once. So I'm going to figure out what I need to do to row 1 here to make it, we'll swap these out real quick. Let's do that here. Because remember, we can swap out the rows so that it becomes 1, 0, -1. And then we've got -2, -2, -4. So what I want to do is I want this position to be 0, and I want this position to be a 1. So I have to figure out what I need to do. Since I already have this 0, I can go ahead and manipulate this first row. And also, if anybody's watching, they want to post in the chat, if you see the step, let me know. Because I like to do math with other people, not just by myself. Anyway, so what I want to do here is I think I'm going to multiply row 1 by a +2. I could do that. Yeah, let's do that. Let's multiply it, so just see what happens. And we'll add it to row 2 in a second. So we've got 2 times 1 is 2. 2 times 0 is 0. 2 times -1 is -2. And then we still have row 2. We'll just put it in here and see what happens. -2, -2, and -4. Perfect. So it looks like when I add these two, I'm definitely going to want to replace row 2, not row 1, because I want this 0 to stay 0. That's the goal. So let's go ahead and do that. We'll just say row 1 plus row 2, replace row 2. And then this helps me keep up track of my operations so that I can repeat them later. So we're going to say 2 plus a -2. Actually, let's go ahead and first put this in here. 2, 0, -2. And then I've got -2 plus 2 is 0. 0 minus 2 is -2. Or rather 0 plus a -2. And then I've got -2 plus a -4 for -6. And it looks like I'm almost done solving it. All I have to do is multiply by scalars now. And so what I'm going to do is, for this one to make, I'm going to employ this concept called the reciprocal. And if you understand reciprocals, basically the product of a reciprocal equals 1. So when you multiply a number by its reciprocal, you're going to get 1. And you find the reciprocal just by honestly just flipping it. So finding that reciprocal of 2 is 1/2, and the reciprocal of -2 would be -1/2. So I'm just going to multiply these rows by the scalar and essentially make those 2's 1. And I think I've finished after that. Still got a little half a board left. All right, so 1/2 times 2 is 1. 1/2 times 0 is 0. And then 1/2 times -2 is -1. And then we have -1/2 times 0 is 0. -1/2 times -2 is 1. And then I have a negative half times negative 6. And I'll just do the math because I don't want to be stuck in my head. Part of the reason why I'm up here is showing, trying to show the math. So I'll be careful about that. So when you're multiplying fractions, you're just multiplying numerators and denominators and then treating the sign. So you have two negatives. It's going to lead to a positive. 6 times 1 is 6. 1 times 2 is 2. And 6 divided by 2 is 3. So I've essentially solved this system. Not very many steps. And so essentially you have x comma y. So we have x comma y equals, it looks like -1, 3. And there's your solution. So what we'll do is we'll go ahead and put the solution up here. We got -1, 3. And since I did that pretty fast in 15 minutes, let's go ahead and verify it graphically and get out the Cartesian coordinate system. Because essentially what we're finding when we're solving these systems is we're finding it's a intersection in the Cartesian coordinate system. So it's at x comma y. So that first component would be your x, the second component would be y. And let's go ahead, and what you have to do is you have to take these equations and you got to put them in slope-intercept form. Right now they're in standard form. So just taking that first equation, 2x plus 2y equal 4, I can rearrange this solving for y by subtracting 2x from both sides. And it's going to give me 2y equals -2x plus 4. And then simply just dividing off the 2 from each value, each term in my equation. So it's going to give me y equals -x plus 2. And if you recall slope-intercept form, you got your slope and your y-intercept. So we'll just simply locate our y-intercept at 0, 2. And that is a actual location on your graph. So we're going to circle that. And then what we're going to do is we're going to perform this rule, rise over run. And when you have a negative slope, a -1, you can either apply that negative to the numerator or the denominator. So you're either rising a -1 and running a +1 or vice versa, which is going to lead to the same line. So it doesn't really matter what you do there. So let's just go ahead and rise a -1, which is going down. Because remember, in the Cartesian coordinate system, it's a positional, and the negative is referring to a direction. So this is the negative y direction. This would be the negative x direction. This is positive x direction over here, positive y direction. So we're going to rise a -1, and then we're going to run a +1. And that's going to put me in another position on my graph right there at 1, 1. And if I use, let me go ahead and get my ruler out so I do a pretty good job. The problem with graphing and finding the solution to systems graphically is just getting an accurate sketch. And if you have graph paper, that's the best thing to do. I do not have a graph paper up here, so we'll just get close and see if we can verify the solution graphically, and then we'll call it good. Unless somebody has a question and they want to post, I'll work for them. That's the reason why I'm really here. But all right, so let's go ahead and take that second equation and repeat this process here, just solving it for y. So we've got 3x plus 2y equal 3. And solving for y here, I'm going to subtract 3x from both sides. It'll give me 2y equals -3x plus 3. Divide off the 2 from everything. And we'll end up with fractions, which are fine. So I've got a slope of -3/2. and a y-intercept of 3/2. 3/2 is approximately 1/2. All right, so we're going to go ahead and locate that slope, or we'll go ahead and locate the y-intercept rather at 1/2, which would be right here. That's 1. And then we're going to use that rule again. We're either going to, so we've got slope of -3/2. So you can either rise, so we'll go ahead and rise -3, and we'll run 2. All right, let's do that. So we're here, and we're going to rise -3. So we're going 1. So we'll go to 1/2. That'll be 2, -1. And what is that putting me way down here at -1/2? So we're here. And then we're running 2, positive direction. So we're going to be 1, that'll be 2 here. So it looks like I'm here. I put a dot here, but it's not really. This is my y-intercept, and then this would be the other point on this graph. And at some point, these are supposed to intersect at -1, +3. -1, how is that going to work? +3. Yeah. -1, +3 is here. It looks like when I draw this line in here, it looks like it's going to work out. Okay, so I'll try to line it up. Let's see if I can get it. That's pretty close. Also, you can always plug these into your Desmos, your graphing feature. And so that's a -1, +3 here. Perfect. So there's your intersection. And you can see visually with Desmos or your graphing calculator, you'll be able to locate that intersection pretty quickly. So, all right, we got another one. So I feel confident with this one. That I did one yesterday, and it was also two variable system. And so the goal is to practice the method with an easier system, and we're going to use the same method with a more complicated system. So honestly, using a matrices to solve a 2x2 is not the most efficient way to solve one of these systems, because you have the algebra and it's pretty simple. But when you get into larger ones, like you could have a system of equations with 50 variables, and you have to have a separate and unique equation for each variable you introduce into your system to solve it. And so I wouldn't recommend doing that by hand, but like a 4 variable or 5 variable is totally doable with this method. And I wouldn't be able to fit the solution on my board. Of course, it's going to take up pages, but at least it's doable. It's almost, I don't know how to solve one of these 4 or 5 variable systems algebraically. I feel like I would have to use a matrices to do it. But the goal is, what I'm trying to do is I'm trying to practice on a simpler one that I'm confident on, so I get a good grasp of the method. That way I can eventually work into a more complicated one. So my goal, and we'll go ahead and end there, but my goal for the future is, like tomorrow, I'm probably going to try to do a 3 variable with the same method, Gauss-Jordan elimination. So we'll see how it goes. I'll probably try to get some of it done in my spare time, just so I'm not completely up here and just, I try to be prepared a little bit. It helps the live stream, but honestly, it's so busy, and we'll just see how the day goes tomorrow. Anyway, all right, I guess we'll go ahead and stop there. That was successful. I got it ended on a good note. And yeah, if you watch my video, thank you so much. I appreciate the support. It is a way of silently supporting me. It makes me feel like I'm not doing math alone up here like a crazy person. And yeah, so I will be back tomorrow, probably working on matrices unless I figure out something else that's more interesting. I'm not bored with them yet. So yeah, I'm going to go ahead and sign off there and say, yeah, I'll see you next time. Bye.